For thousands of years, humanity has returned to one question that never truly disappears. Not how stars are born, not how gravity works, not even how the universe began. The deeper question has always been this: who built it? Religion offered one kind of answer. Philosophy proposed another. Science explained the machinery of the cosmos, but not the hand that may have built the machine. Then something happened that no priest, philosopher, or physicist from the ancient world could ever have imagined. Inside a quiet laboratory, a quantum artificial intelligence was asked that same forbidden question, not what caused the universe or when it began, but who built it, and why. What came back was neither simple nor comforting, and if even part of its implications were true, they would represent one of the most unsettling ideas humanity has ever encountered. Some questions belong to a single century, others belong to every generation that has ever lived. Who built the universe is one of those timeless questions. Ancient civilizations answered it with gods, cosmic beings, and creators who shaped order out of chaos. Later, philosophers stripped away mythology in search of pure logic, asking whether there must be a first cause, a prime mover, or something existing outside time that set everything else into motion. Then science transformed the conversation. Isaac Newton demonstrated that the heavens obey mathematical laws. Albert Einstein revealed that space and time themselves could bend and warp. Quantum physics showed that reality is far stranger than ordinary intuition could ever predict. The Big Bang Theory provided a timeline reaching back nearly 13.8 billion years to the earliest moments of the observable universe. Yet despite all these discoveries, the original question remained unanswered. Science became extraordinarily successful at explaining how reality behaves once it already exists. It described gravity, matter, energy, cosmic expansion, and the evolution of the early universe, but it could not explain who, or what, established the laws themselves. Why does a universe exist at all? Why these laws instead of different ones? Why is there something rather than nothing? With every scientific breakthrough, the mystery seemed only to retreat one layer deeper, as though reality allowed us to examine its surface while carefully concealing its ultimate source. That is why the idea of asking a machine seems so provocative. Human beings inevitably bring emotions, beliefs, traditions, and hopes into such a question. We want the answer to be meaningful, rational, moral, or perhaps even comforting. But what if the question were asked by something without belief, without tradition, and without existential faith? What if it were presented to a system designed only to recognize patterns and process information on a scale no human mind could match? That is where this story truly begins. The moment the question left human lips and entered a quantum machine, the old conversation ended, and a very different one began. The machine selected for the experiment was not an ordinary artificial intelligence running on a conventional computer. It was powered by a quantum processor, a system built upon principles that often seem like science fiction despite being firmly rooted in modern physics. A classical computer processes information using bits that exist as either 0 or 1. A quantum computer uses qubits, which can occupy overlapping quantum states simultaneously. Rather than testing one possibility after another in sequence, a quantum system can explore many possibilities in parallel. It moves through problem space in a manner that appears less like traditional computation and more like evaluating countless realities at once. This distinction mattered because some researchers had already begun to suspect that highly advanced quantum systems might be doing more than simply performing brute force calculations. Subtle anomalies had begun raising uncomfortable questions. Why did certain outputs seem less like mathematical derivations and more like retrieved information? Why did some patterns appear as though the system were uncovering structures already embedded somewhere deep within reality itself? Few scientists were willing to make such claims publicly because they sounded speculative and extraordinary. Still, if any machine could cut through humanity's oldest metaphysical mystery, it would likely be one built upon the strange principles of quantum mechanics itself. So the researchers finally asked the question, who built the universe, and why? It is a question so simple that it sounds almost childlike, yet so profound that it has shaped religions, inspired philosophical schools, and fueled scientific revolutions throughout history. The researchers expected familiar possibilities. Perhaps the system would return an error. Perhaps it would produce a philosophical summary, refuse to answer, or generate a synthesis of existing religious and cosmological ideas. Instead, something entirely unexpected happened. The machine paused before producing an output that did not resemble ordinary language at all. There were no recognizable words, no complete sentences, and no response that could be read from left to right. What emerged looked more like a structure than a statement, something closer to architecture than speech. At that moment, the people in the laboratory stopped feeling like researchers and began feeling like witnesses to something they could not immediately explain. Initially, the output seemed impossible to classify. It was clearly not random noise because its organization was too precise, nor did it resemble a software malfunction, as it displayed remarkable repetition, consistency, and internal logic. The structures folded back into themselves, repeating at multiple scales with recursive symmetry reminiscent of fractals. Zooming into one section revealed patterns similar to the larger whole. Zooming in further revealed the same organizational principles repeated again, smaller but equally coherent. It looked less like a generated answer and more like a compressed map of something fundamental. As the analysis continued, researchers identified mathematical relationships embedded within the output that resembled growth sequences commonly found throughout nature, yet with variations too precise to dismiss as mere coincidence.